Okay, YouTube, in my last couple of videos here, we've been looking at box plots as well as testing for outliers. And what I want to do in this video is kind of follow up with those two and look at a different way of representing a graph, which is as what we call a stem and leaf plot, okay? And we'll just go ahead and get into this. We say it gets its name due to the fact that it has a central column or stem from which the data is listed laterally, like a leaf here. I don't know. I suppose I give you a stem and leaf plot here. I should have used green. It's kind of like here's the leaf and here's the stem of a plant. I don't know. You can imagine it that way. But the idea here is this: stem and leaf plots are very good at showing us how data is distributed in a way that is very similar, if you ask me, to a frequency distribution where we organize it into a table, but also as kind of like a bar graph or a histogram. It's kind of the best of both worlds at once. So what I want to do here is this. I say consider the data for Class C's performance above. And when I say Class C, we had discussed previously 3 different classes that had performed on a prob stats quiz, say. And we have Class A, Class B, and Class C. And we had compared them by looking at their box and whisker plots here. But looking at Class C's data, which I have also listed over here, what I've done is I've already organized this into a stem and leaf plot. So I'm going to share with you the essential parts of a stem and leaf plot, talk about what are the good things that this would show to an audience here, and then what we'll do is we'll create our own stem and leaf plots for the performances of both Class A here and Class B, which is this box and whisker plot here in this set of data here. So essentially, when we talk about a stem and leaf plot, one thing to tell you is this: it's always good to put your data in order, but it's actually not a necessity when it comes to stem and leaf plots. You can just go ahead and create one because what we see here is this central stem. What it does is it corresponds to what we call the lead digit on every one of these numbers here. We sometimes have lead digits, but in this case, since they're all 2-digit numbers, you'll notice that our numbers are anywhere between the 60s, 70s, 80s, and this one here in the 90s. So when we talk about lead digits, that's what you're populating your stem with here. And what we're saying is that each of these classes, is what we've called them before when we organize this into a frequency distribution, each of these classes represent data that are in the 60s, 70s, 80s, and 90s. So for instance, like the 69 right here, I put a 6 right here. What does this 9 over here represent? It represents the trailing digits. So we can say the stem here is the lead digit, and I'm going to say that sometimes you have lead digits, but is a lead digit, whereas the leaf is the trailing digit. And so when you read a stem and leaf plot, I actually didn't know how to do this for a long time growing up, and then I learned it. I was like, oh, that's easy. Essentially, you say, well, you get a 60 and a 9. So we say 69, and then when we list the rest of these, it is good to put the data set in order, essentially. I guess I should say this. You should put your data set in order. You can go through and cross things off as you go anyways, but it's something I do in my head, but I'm going to be a good person here and say, okay, you should put your data set in order. But when we put this data set in order, we'd say 69. I notice that I have a 70 as the next higher digit. So I say, or next higher number in the data set. So we say 70 would be a 7 followed by a 0. And then I notice that I have a 74 and a 74. So I get a 7474. And then 2 70s, 5. So we say 75, 75, and then a 78. Okay. And no more numbers in the 70s. Okay. So the last 3 data that we have here are 80 and 82. So we have 80, 82, and then we had a 91. So 91. But essentially, what I want to point out here is this: I say, what patterns do you see? From this should be a from the raw data to the data in the stem and leaf plot. When you put this in order here, you can see that the overwhelming majority of our data lies in the 70s class. Okay, we could call this the modal class. Because it has the most things in it, the highest frequency of things in it, okay? And I say, well, what do I notice about repeated data points? Just because 74 shows up here twice doesn't mean you list it once down here. You actually list it as many times as it shows up. So if all of our data in the 70s was a 74, we would write 74, 4, 4, 4, 4, 4. 6 74s, we would still write 6 4s, okay? And then last but not least, we say, what is a stem and leaf plot good at showing? Well, what I want you to imagine is this. If you were to, essentially create a histogram from this, where we say, this is kind of the class values, and that's supposed to be a C. Class values. We say like 60s, 70s, 80s, 90s. We could say, 60s, 70s, 80s, 90s. This is really crude, okay? But you would say that, you know, not many in the 60s. We had one thing there. We had like 6 things here. It'd be 6 times as high as that bar right there. And then 2 things here, and then 1 thing here. And so what I can tell you is a stem and leaf plot is kind of like a histogram, but whereas a histogram gives you the data in bars but doesn't actually tell you the original data, this doesn't give you bars, but it kind of does. And when you put these in order neatly, what you can see is you can see how many data are in each class, but also this, how, you know, what the actual data values are. So it's kind of like a raw data, if you ask me, like a raw data sideways histogram, which is a cool thing to have, okay? So from things like this, we could actually indicate things like range. We could say, well, the range is 91 to 69, you know, max minus the min. We could even find the median. It's weird to count in for the median here. I'll do it one time, but we say counting in, we say in. You know, we say from the 2 here and to the 70 here. And then, you know, count into the 80 here, and then we'd count in one way this way. And then from here to here, and then you land in this middle one here, we say that the median is 75. You know, I don't always recommend finding the median with a stem and leaf plot, but it is a possible thing to do, okay? So we're going to construct our own stem and leaf plots for these other 2 classes here. This was class C. And when we go back and, you know, maybe observe their box plots here, we say class C did better than class B. I would say the middle 50% of kids did about, you know, the same on the quiz, but we'd say we had an upper outlier here, whereas this one had a lower outlier here, and they had big spreads. And then class A, we're going to find out, it was all really packed together between, like, you know, 80 and like 91 here when you look at their data, 80 and 91. So how does this make their stem and leaf plots look? Well, what we want to do is, first of all, when you make a stem and leaf plot, determine what your lead digit or lead digits should be in the stem. So I notice here that class A was anywhere between, you know, from the 80s to the 90s. And I've already put this in order for us here just to be clean about it. But we say 80s to 90s. So we say, really, you know, just to compare these best, maybe I'll go from 6, 7, 8, 9, you know, and I'll make all of these stem and leaf plots look the same just to compare them. But we say, here's the leaf. And we could even say that these are scores on a quiz, scores, give it a title. So when we put these things in, we had nothing in the 60s here, nothing in the 70s. We have 80, so 80, 81, so 81, 82, 84, 86, 88, 88, 90, 90, and 91. So our stem and leaf plot, you can see that everybody's kind of packed into the upper end of this distribution, whereas down here, now, this one, I don't have the data set in order, so let's go ahead and put this in order. Be a good person here and make us do this. So we say 60, 60's gone in the 70s. It looks like we have a 70 here. So 70, any other 70s? No, going once, going twice. We say, okay, so 73 is, I think, the next data value that we see here. It's data value, 74, 74, 75, so 2 75s, 79, and now we're hopping up to the 80s. So we say 80, 82, 85. And just to be clear, I want to make sure I have all my data here. Excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 data to begin with. So we're creating our stem and leaf plot. Since I am comparing these, I only need to go from the 60s to the 80s here, but because I wanted to compare these data sets all to one another, let's make them consistently the same number of classes and the same type of classes here. And I know that this is very crudely drawn by hand. If I did this on paper, I'd use a straight edge. But we'd say 60, we say, okay, so 60, that's our only data value that we had in the 60s. We say, okay, so 70, 73, 74. So we have 70, 73, 74, 75, 75, 79, and then 80, and 82, and then 85. So when we compare these stem and leaf plots here, we can easily tell that actually, again, Class A was the best performer on this quiz, because I would say that they are very packed together and all of the scores were in the upper end of the distribution, whereas when you compare classes C and B, we said that, well, when we looked at the box plots here, C outperformed B, but because B had a lower outlier and C had an upper outlier, but the middle 50% of the data did about the same. So we noticed that a lot of scores in the 70s here on Class C, but Class C, we said, outperformed Class B. This had just as many scores in the 70s. So when I say outperformed, I would say outperformed by a lot. Well, look at this. We had one score down in the 60s, whereas this one had one score down in the 60s. But compare what these scores were. This was a 60 and this was a 69. So more towards the upper end of this class. And then we'd say that this had 3 data values. Class B had 3 data values in the 80s. This had 2 data values in the 80s, but 1 in the 90s. Okay, so more heavily stacked on the upper end, and this was more on the lower end, even though they were both similarly packed in the middle. So you could describe these by describing what classes the scores lie in. Cheers.